So today we have a total charge problem regarding the free amino acid histidine. So it's basically asking us the total charge of the free amino acid histidine at the pH of 5.0, and it gives us the pKs of the ionizable groups of histidine, which is the alpha COOH, which is 2.3, and then the ring, the end-metabolic ring, is 6.0, and then the alpha NH3 plus, which is 9.6, right? So let's write down here. So the alpha COOH, let's change this, right? Yeah, so the alpha COOH, its pKa is 2.3, and it forms COOH, which is neutral, and COO minus, which is a -1 charge. Now let's just make this a little smaller. Excuse my handwriting, right? Put it right here. And then we have the imidazole ring, right? So the imidazole ring, side chain, right? pKa is 6.0, and it forms protonated imidazoleum, positive charge 1, right? Excuse my pronunciation. I have a little bit of a speech impediment, but I am working on it. And then we also have a neutral imidazole, which is make the charge 0, right? And then we have an alpha NH3 plus, and the pKa for that is 9.6, and it forms an NH3 plus, which gives us a +1 charge, and then it forms NH2, which gives us a 0 charge, right? And let's just make this a little smaller. Like I said, excuse my handwriting. Didn't mean it to write that bad. So we're gonna put it here. Yeah. All right, so the rule is that when a pH is less than the pKa is protonated. So let's just write the rule, right? pH is less than pK. When pKa is greater than pH, or when the pH is less than pKa, it is protonated. And when the pH is greater than the pKa, it's deprotonated. So let's just keep these two rules in mind, right? And we're just gonna put it here. We'll get this out the way. Make this a little bit more smaller. Yeah, right here. So these are the rules that we need to keep in mind, because we're comparing the pH 5.0 to each pKa, right? So for the alpha COOH, the pKa is 2.3, which is right here, right? And the question is the pH 5.0 higher or lower than 2.3? So the pH is higher than the pKa. And that tells you that it won't be COOH, it will be COO minus. That's why I have the O minus right here. And that charge will be a -1 since it's deprotonated. Let me just -1 charge. Right? And then the imidazole, right? The imidazole, it is 6.0. As we can see, 6.0. And we're comparing it to the histidine pH of 5.0. So the pKa is greater than the pH, so it will be protonated, right? And that will be a +1. Okay? And now let's go to the alpha NH3+. So our alpha NH3+ is 9.6 right here, as we can see. And like I said, we're comparing it to the pH of 5.0. So is the pH 5.0 higher or lower than 9.6? The pKa is obviously higher, right? And because the pKa is higher, it's going to be deprotonated. And then after that, now we're going to just add the charges, right? So the formula is going to be the total charge equal COO over COOH plus the imidazole plus the NHA3 over NH2, right? So this is the formula to, obviously solve it, right? So the total, matter of fact, it's another way that's simpler, the way we can do this, right? So instead of just doing that formula, we can just do it this way. This is -1, right? No, sorry. Wait, so 6.7. Oh, sorry, guys. This is +1 for the NH3+. It is protonated because the pKa is greater. So +1, right? +1. And then we have +-1. We know this is 2. You -1 from the 2, and we get +1. So this will be the total charge of histidine at pH of 5.0.